Alright, so we're talking about properties of equality, and the first one that we're going to talk about is the addition. Whenever you see POE, that means property of equality. So the addition POE, what does that mean? It just means that we add the same value to both sides. Okay, so I've got an equation, and I add the same value to both sides. So most of us know how to do this. We do it all the time without thinking about what we're doing. So my example, when I've got an equation that says x minus 4 equals 10, what do I do to solve that? I add 4 to both sides. Of course, then I would get x equals 14. So that step, the justification for this step would be, why can't I do this? My reason is the addition property of equality. Okay? Well then, shouldn't be too hard to think that there's also a subtraction POE. So again, subtracting the same value from both sides. So if I have x plus 5 equals 20, again, I subtract 5 from both sides. Why can I do that? Why is that? What's my justification? Because of the subtraction property of equality. So again, my answer would be x equals 15. Okay, think about what you think would come next. No surprises. There's a multiplication POE. Just means you multiply both sides by the same value. That's what I do when I do this one. X divided by 3 is equal to 10. How do I solve this? I multiply both sides by 3. And so my justification for that would be the multiplication POE. There's also a division POE, when we divide both sides by the same value. So if I have 3x equals 21, I would divide both sides by 3 to get my answer, but my justification, my reason would be because of the division POE. Okay, the reflexive POE, just means, it's kind of funny to say this, but you're saying the same thing. It means it's exactly the same. So for example, a plus b equals a plus b. Yes, that's true because of the reflexive property of equality. Or the measure of angle A equals the measure of angle A. Sounds funny to say it now, but we're going to do some stuff coming up where we're going to make use of that. Symmetric POE, it's a mirror image. So a plus b equals b plus a. Or AM equals MA. That's what's called the symmetric POE. Substitution POE. We replace one value with an equal value. So let's say that I'm told the measure of angle 1 equals 90. And let's say I'm told the measure of angle 1 equals the measure of angle 2. Well, then I can substitute. If angle 1 equals 90, then I can put measure of angle 2 is equal to 90, because I can just substitute the 90 for the measure of angle 1 if angle 1 equals 90 degrees. So I just substituted 90 degrees in for angle 1. Okay? Syllogism, or we call this one the transitive property of equality. Well, if the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, doesn't it stand to reason that the measure of angle A equals the measure of angle C? Again, we call that the transitive property. Just think syllogism. The distributive property, again, you've done this one for a while. So if I have A times parentheses B plus C, we just run the A through and I get AB plus AC. So example, 3 times x plus 2 gives me 3x plus 6. So those were all properties of equality. There's similar things talking about congruence. Put a little line over here. I didn't put that line in there. Just draw a little line over here. So the reflective POC, or the reflexive property of congruence, segment Rx is congruent to segment Rx. Shocker. Okay. Symmetric POC, mirror image, segment Rx must be congruent to segment XR. In the transitive POC, if segment Rx is congruent to segment PQ, and if segment PQ is congruent to segment MB, then segment Rx must be congruent to segment MB. Okay, so why do we care about this? What's the significance? We're going to do an algebraic proof. We'll do some in class, and that's going to lead us, our steps will lead us into doing geometric proofs. So for example, this is what our algebraic proof is going to look like. We're told that negative 5 equals 3n plus 1. What we're asked to prove is that n is equal to negative 2. So I need to show that, and we all know how to do this, but let's think about the steps that we take and how we justify those steps. Okay, so I'm going to make a little 2-column proof. So I've got my statements on this side and my reasons on this side. So my first statement is always what I'm given. My first statement is always what I'm given. So I'm given that negative 5 equals 3n plus 1, so that's my first statement. Well, how do I know this is true? Because it was given to us. Okay, so think about what my next algebraic step would be to solve this. trying to get the n by itself, so I would subtract 1 from both sides to move this 1 to the other side. So then my next statement would be, after I subtract the 1 from both sides, I would be left with negative 6 equals 3 times n. And what step did I do? What did I did the subtraction property of equation. So this is why this one is true. Okay, think about what my next step would be. I need to divide both sides by 3. And if I do that, then I'll get negative 2 equals n. And what did I do? How do I know this is true? How do I know that I can divide both sides by 3? Because of the division property of equality. And this next part to me is kind of silly because I have proved it. This one says n equals negative 2, and I've proved that negative 2 is equal to n, which to me I would settle for that. But if I want to make it look exactly like this, I'll write n equals negative 2. So I just flip these because of the symmetry property of equality. Keep these handy, don't lose these.